quadratic functions in all three forms and how we can go about solving a quadratic equation that's not factorable. So the first thing we have to think about is, how do we find the roots of a quadratic function? So in order to do that, we can set f at x equal to 0, solve for x, and the solutions, or the x-intercepts, the roots, the zeros, okay, can be found. We can do that by graphing the function on the TI and spire and looking for the x-intercepts, or factoring the equation and solving the resulting linear equations. However, we don't always have a calculator that'll graph for us, and we don't always have the ability to factor an equation. Let's think about this word problem here. We've done lots of questions like these. The sum of a number and twice its square is 310. Find the number. So let's highlight the important stuff. The sum of a number twice its square is 300. Find the number. What am I looking for here? The sum of a number twice its square is 310. I'm ultimately looking for a number, which is x. Okay? So sum tells me to add. A number twice its square means I'm going to multiply 2x its square. Oh, that means I'm going to take 2x and I'm actually going to square it, and it equals 310. So I'm adding something. I'm taking 2x squared, I'm adding x, and it has to equal 310. Oops, I didn't want to do that yet. So the first thing I should do, because this is a word problem, is I should introduce my variable. So let x represent the number. And of course, I'm not writing very neatly, and you'll see it neatly on the next slide. You should copy the next slide, not, of course, my messy handwriting. Now I know to solve a quadratic equation, I need to have all my terms on one side and have it set equal to 0. So I'm going to move the 310 to the left. And now I need two numbers that have a product of negative 610 and a sum of 1, and those numbers don't exist. I can't solve it right now. So now I'm going to work with the quadratic function and put it into vertex form by completing a square. You're going to love this. It's so much fun. Well, for me it is anyway. So I need to factor out the a, and I've got an x squared. And when I factor out an a from this, remember, it was like dividing through by a. Let's see. So far, so good. I haven't done anything difficult, just completing the square like we did yesterday. Now, I have to force my perfect square trinomial, and that means I take this b over a, and I have to divide it by 2. Well, whenever I divide by 2, I can rewrite that as divide by 2 over 1. Whenever I'm dividing fractions, I can change the divide to multiply and take the reciprocal of the number that follows. So really, that's b over 2a. So what I'm going to do is I'm going to take b over 2a, and I'm going to square it. But I have changed my equation, so I have to subtract it off to keep the equation balanced, and I'm still leaving my c out there. This is pretty ugly so far, because I've got all these fractions, but it's really not that bad. It's just ugly because it's messy. I can square b over 2a, so I get b squared over, don't forget to square the 2 because it's also affected by the exponent, so it's b squared over 4a squared. Subtract b squared over 4a squared plus c. Same problem as we always have when we complete the square. I only want the 3 terms that make my perfect square trinomial to be in the bracket. So I have to distribute the a in front of the brackets right here with this. So I get plus a times negative b squared over 4a squared plus c. And don't forget, this is like a over 1. I can factor. Sorry, I forgot the exponent there. Square root of b squared is b. Square root of 4a squared is 2a. The a here reduces with the a there, and I'm left with minus b squared over 4a plus c. So I end up with a times x plus b over 2a. And I like positives first, so I'm just going to write this as a positive first. It really doesn't matter. It's just easier to work with, in my opinion, if I see the plus first. I need a common denominator. So if I want to make this a 4a, I've multiplied the denominator by 4. I have to multiply that. Oops, sorry, guys. Okay, sorry about that. If I multiply this denominator by 4a, I have to multiply the numerator also by 4a. And I have, I keep forgetting exponents here, sorry guys. I have plus 4ac minus b squared all over 4a. Now that's fabulous. That looks marvelous to me. Still doesn't help me, but I can see the x-coordinate of the vertex is minus b over 2a, and I can see the maximum value is always this ugly mess here, which I would never remember. If I remembered x equals negative b over 2a and found the x-coordinate of the vertex, I would substitute that value into the original equation to solve for the maximum. That still doesn't help me solve for the zeros, though. What do I know about the zeros? I know that for the zeros, see how much prettier it is here for you to copy? I know for the zeros that f at x equals 0. So I'm going to set that all equal to 0. So I've done that. What's next? I'm not going to write this out because it's just going to get cluttered and really hard to follow. I need to solve for x. So I'm going to move this term here, this a times x plus b over 2a squared to the left side. And when I do, it becomes negative. Now, ultimately, I need to get x by itself, and we know that when we solve any kind of equation, we have to do it by solving BEDMAS backwards. So brackets are going to be the last thing, then exponents. So I need to get rid of this minus a. So I'm going to divide both sides by negative a. So when I do that, I'm left with x plus b over 2a squared on the left. And remember, a divide by a, negative a, is the same as a multiply by negative 1 over a. So I end up with negative 4a squared in the denominator. Or you'll see what I did here. I multiplied the negative into the numerator. Let's just show you this. 4ac minus b squared over 4a times, I put the negative in the numerator, negative 1 over a. So that became negative 4ac plus b squared over 4a, which I then rewrote this way. I put the b squared first because it was positive. It doesn't really matter which way we do it, as long as we use proper mathematical reasoning. Now, what happens next? I have this lovely, ugly mess here. I need to get x by itself, so I'm going to get rid of the exponent next. And I do that by taking the square root of both sides. And because I don't know whether what I started with was positive or negative, I have to put this plus or minus in front. It's very important. The last thing I need to do is move that minus b over 2a, or sorry, the positive b over 2a to the other side to get x by itself. And if it's positive on the left, the way to get rid of it is to subtract it, so I have to subtract on both sides. Last thing, I need to take the square root of this mess here. Well, b squared minus 4ac, I can't do anything because of the negative sign there. But I can take the square root of 4a squared. So I can split it up and leave it as root of b squared minus 4ac all over 2a. And I notice now I have a common denominator. So it can be written as x equals negative b plus or minus square root of b squared minus 4ac all over 2a, which is known as the quadratic formula. And don't be frightened, I'm never going to ask you to derive that on a test, but I do think it's important for you to understand where it comes from. And if you actually followed that and got it, then you should be really good at completing the square, because doing it with letters is always very different than completing the square with numbers. So the quadratic formula is x equals negative b plus or minus b squared minus 4ac all over 2a, and it can be used on any quadratic equation, and it has to be in standard form. That should say quadratic equation, sorry guys. Everything has to be set up equal to 0 before we can identify a, b, and c. The hardest part about the quadratic formula is remembering the formula, which I'm not going to give you on the test. So there's a song, Pop Goes the Weasel. I don't know who came up with it. I would love to give credit where credit is due. Somebody out there came up with this, and a student of mine years ago heard it somewhere and taught it to me. So it helps me remember it. It helps other people remember it. It's up to you if you want to sound silly. During your test, if you're humming Pop Goes the Weasel, I will not get upset. Now, next year's teacher might, but I'm not going to. So remember, you're singing to Pop Goes the Weasel. Okay? X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So you too can sound silly just like I did. Okay? So we're going to use the quadratic formula. The first thing I need to do is identify a, which is negative 2, identify b, which is positive 8, and identify c, which is negative 3. Okay? Then I'm going to start by writing my quadratic formula. And I can sing it, I can say it, but I always want you to start your questions by writing out the formula because that is going to help you to remember the formula. So again, sing your Pop Goes the Weasel song. X equals negative b plus or minus square root b squared minus 4ac. Make sure the line goes all across. All over 2a. It's cheesy, but for some of you, it's a good memory aid for learning it. Now, what I also suggest when you do this, everywhere I see a variable, I just toss in brackets right away. Make sure your divide sign goes all the way across and your radical goes all the way across. Now, your b value is positive 8. That's going in here. A was negative 2, C was negative 3, and A is negative 2. Always good to start out by writing everything. Negative 8 plus or minus square root positive 64 squared. I'm using bed math here again, guys. Negative times negative times negative is negative. 4 times 2 times 3 is 24. All over negative 4. X equals negative 8 plus or minus square root of 40 all over negative 4. That's what's called an exact solution. You have two answers because of this plus or minus here, and it's an exact solution. We haven't rounded anything, and we can't take the square root of 40. If you move on and you go to 11U or you go to college in technology math, you're going to learn how to simplify that question a little bit more, but we're not going to do that here. Okay, so now we've got that. We can branch off and take the square root of 40 on our calculator, do one answer where we've got positive 6.324 and one answer where we have negative, and we get two roots. Now, what do we know about this function? We know it opens down, and it's going to cross the x-axis twice because we got two roots. Okay, we know it opens down because a was negative. And if it opens down and it crosses the x-axis, we can also draw the conclusion that the vertex is above the x-axis. Now, if we go back to this question we started with at the beginning of class, now we have all our tools to solve it. A is positive 2, B is positive 1, because the number in front of x is a 1, and negative 310 is C. And we plug all of those numbers in exactly the same way. And you can do this on your own for practice. And we end up with the exact value of the number, are those things, oops. And we get some ugly decimal numbers, okay? Never said the answer had to be nice. If it asked us for natural numbers or whole numbers, we would have to say there's no solution at those and that those roots are inadmissible. But it didn't ask us for that, okay? Have a good night. Oh, wait, homework, fun stuff. Exercise 2, page 4, number 1, 2BDHI, 3ACE, and 4ABE. Thanks, guys. Have a great night. Good night.